Hi Nines, and welcome back to my shed. Okay, in this lesson we're going to be looking at specific latent heat. Now just to go back a few lessons, if you remember, we spoke about internal energy of a substance, and we said the internal energy of a substance is a measure of the kinetic energy and the potential energy of all the particles. The kinetic energy is due to their motion, isn't it? And the potential energy is due to the bonds between them, their positions. So we saw this graph as well, and this graph we can think of as being some sort of experiment we've done where we've got a block of ice and we've put a Bunsen burner underneath and we are heating this thing up, and what we're doing is we're taking a temperature measurement every sort of unit of time, and then we can plot a graph and see what happens. Now if we think about just the internal energy at the moment, at all points we are increasing the internal energy of this substance because we are constantly heating it. We've constantly got that Bunsen burner underneath. So here we can see the temperature is increasing, and we said that temperature is the average kinetic energy of the particles. So the average kinetic energy of the particles is increasing. So here we've got a kinetic energy increase. Kinetic energy going up, that means internal energy is obviously going up. What's happening here? Well, we don't see a kinetic energy increase here because there's no temperature change. So what we are doing is now increasing the potential energy here. So this is the potential energy, and then eventually we start to see an increase in temperature, so again we're getting a kinetic energy increase. Now kinetic energy tends to be quite an easy thing we can come to terms with. We spoke about kinetic energy before in terms of the movement of any object has a kinetic energy. Remember, we've used that equation, that half mv squared. Potential energy is a little bit harder for us to get our heads around, but I've got a simple analogy for you. Now we can perhaps think of this potential energy a bit like magnets. So here I've got a couple of magnets, and in a solid we can think of these things as particles, and they're constantly jiggling around. Well, if I start to increase the temperature of these things, put heat energy in, they're going to be jiggling around faster and faster and faster. And let's think about this potential energy. How about if I pull these things apart? I'm putting some work into this to move these things apart slightly. So now there is a potential for them to release that energy. And in the case of these magnets, if they snap together, you can hear that sort of sound being released. Okay? And if I can put more work into these things, I can bring them apart even further, and then the energy release when they come back together is greater. The sound is more. So that's one way we can think of potential energy. Now, how do we do some calculations in this? Well, remember when we've done specific heat capacity, and we said specific heat capacity, the calculation that we use for that is the change in energy is equal to the mass of our substance times by its own specific heat capacity times by the change in temperature. Okay, so that's fine for these bits where we've got a kinetic energy change because we've got a changing temperature. However, at these points here, we can't use this equation to calculate how much energy we're putting into this thing. Let's think about what's happening at this point here. If this was a block of ice, we could say that this temperature is at 0 degrees. And we could say that this temperature up here is at 100 degrees. So what do we think is happening at this point at 0 degrees? So at this point we're getting a state change. We're changing from a solid into a liquid. So how much energy do we need to put into this block of ice to change it from a solid into a liquid? So the equation we can use is for specific latent heat. So specific latent heat is the amount of energy you need to put into a certain mass, and that mass has got its own specific latent heat. There's a few different names we use for this. So we use specific latent heat of fusion when we're talking about going from a solid to a liquid. Or we've got specific latent heat of vaporization when we're going from a liquid into a gas. Okay, so this has its own particular number for each certain substance, exactly the same as C has its own number for each substance. Okay, so that is specific latent heat. So if I want to calculate how much energy I'm putting into this thing to increase its temperature by this amount, I use specific heat capacity. And if I want to know how much energy I'm putting in to, in this case, melt a certain amount of substance, I use the specific latent heat equation. Quite an easy one to rearrange because these are all timesed. So if I want to get rid of, for instance, the L on this side, I simply divide both sides by L. It cancels out. So I've got E over L equals M. Okay? So there's a brief run through of specific latent heat. Now I'll send you a PowerPoint out, and I'll do a voiceover with the PowerPoint as well, so you've got a bit more information there. And I'll also send you some questions, because I know you love doing lots and lots of questions. And then you can send me the answers and I'll go through those and see how well you do. Okay? Hope to see you soon, Year 9s. Stay safe and keep learning about physics. Bye-bye.